how we are going to cover this unit. Firstly, we introduce this topic, then we'll cover the core concept of the Fazan's rule, then we'll discuss. After that, we'll have some questions regarding this topic. So, Fazan's rule. Okay, previously we have studied that there is no 100% covalent character and the ionic character present in a molecule. Going to see a live concert of a celebrity. Okay, you went there and saw that the people are just scattered over a space, like they are doing some work, they are busy in their own pace, some are talking, some are listening, some are they're busy. Okay, so when the celebrity gets into the stage, okay, on that particular time, what will going to happen? The crowd will try to come into the frontier line. Okay, so can I say the celebrity has a special kind of power to attract the people towards itself? So like that, the cation has a special kind of power to attract the electron cloud towards itself. Okay, let's understand very deeply. So we know that the cation has a smaller size. Why the cation has a smaller size? Can you please tell me? Can you please tell me why the cation has a smaller size? Just because of that Z effective value, right? So this is the anion. Okay. So this is cation and this is anion. Anion has a larger size. Why the anion has the larger size? Just because of the electron present in the anion in its outer orbital is more, so the electrons are get repelled by each other, so the size of anion has been increasing, right? So say that the cation has the smaller size, and the anion has a larger size, like this. Okay, and as the cation has a smaller size, so the charge on it is concentrated. So what is going to be happen when a cation approaches to anion? Not necessarily that always the cation will approach the anion, sometimes anion also approach the cation. So I can easily say that when the cation and anion approaches together, so we know that both the cation and the anion has a electric field. So if cation is in the electric field of anion, what is going to be happen on that particular time? The cation, the charge is condensed in the cation, so it has the tendency to attract the electron cloud of anion towards itself. As the anion has a larger size, so the attraction force between the outermost cell and the nucleus is lower, so the cation has the power to attract the electron cloud of anion towards itself, is known as the polarization power. Okay, while the anion has a tendency to deform, attract the electron cloud of an anion or to polarize an anion is known as the polarization power of cation. Got it? As the polarization power of cation is directly proportional to the covalent character of a molecule, while the polarizability of anion, yani ki the tendency to deform its shape when cation is present, so this is called as the polarizability of anion. Okay, so this is directly proportional to the covalent character. Hope this is clear to you all. If you have any doubt till now, then you can ask me. Okay, now coming to the next slide, you can see the cation approaches to anion. If the size of cation is smaller, then the charge of cation is concentrated more. So if the charges is concentrated more in it, then it has the higher ability to attract, to deform the electron cloud of an anion towards itself, right? If the size of cation is large, so the attracting power will decrease, right? So the size of cation defines the covalent character also. So I can say if the size of cation is increasing, then the covalent character will decrease as it's inversely proportional to it. Okay, NaCl, lithium, LiCl, NaCl, KCl, CSCl. Okay, so can you please tell me in which has the more polarizing power? As we know that the size of cation is increasing, then the polarization power will decrease. So the cesium has the larger size, so it has the less polarization power, right? So can you please tell me the order of the covalent character? Right, is the actually the lithium has a smaller size, so it has a more tendency, the ability to attract the electron cloud to itself, so it has more covalent character in it. Okay, then sodium, then potassium, then cesium, right? The second term is the charge on cation. The charge on cation. The charge